We are going to study today about Biot Savart law. Biot Savart law, Biot Savart law, Biot Savart law. What is the Biot Savart law? Basically, a Biot Savart law was given by two scientists in the year 1820. Ta-da! This was a discovery rather than a logical theory. They discovered that how does a wire carrying current produces a magnetic field. So as you can see, what do scientists do? Every single moment they keep on doing experiments, researching, finding new things in this world. So same was done by these two scientists. They were continuously doing experiments, taking wires, passing current through them, and seeing what effect this current produce, and how would this wire carrying a current produce magnetic field. So in our diagram, as you can see, there is a wire, and the wire is named XY, and it is carrying a current from the position X to the position Y. So it's carrying current from the position X to the position Y. Now if I need to find the magnetic field, say at a point P, which is at a distance say R from the wire. So this is the point where we need to find the magnetic field due to the wire. Rather than finding the magnetic field due to the wire, what they say that let us find the magnetic field due to a very small segment of the wire. Let this segment be named DL, where it is a very small segment of the wire for which we are going to find the magnetic field at point P. So for that they did experiments after experiments after experiments. Is this segment of the wire producing the entire magnetic field at the point P? No, it is producing a very small amount of magnetic field, which is dB. So it is producing a very small amount of magnetic field, dB. Now as we know, so magnetic field is a vector, so we give a vector sign over here. Let's see, what did these two scientists do? These scientists did experiments day after day after day, and after their compiled experiments, when they saw the results, they analyzed the results, they came into a conclusion. They said that the magnetic field at point P would depend on, number one, obviously on the amount of current flowing. It's very true. You will agree to it, I will agree to it, everyone will agree to it. So the magnetic field will be proportional to the amount of current flowing through the wire. Now can you guess what all other things can it depend on? Yes, just think of it. Can you guess what other things will it depend on? Yeah, yeah, you are correct. It will also depend on the length of the wire, that is the small length. Had we taken the greater length of the wire, the magnetic field would have depend on the greater length. It will also depend on one more factor, that is, see, if this is the direction of the measurement of the magnetic field, it will depend on the angle theta. It will depend on the angle theta with which the direction of measurement makes with the direction of flow of current, which the direction of measurement makes with the flow of current. So it will depend on sine of this angle, that is sine of angle theta. Yeah, very good. Now isn't it logical, isn't it very logical that it should also depend on the distance r? Because had this point be at a far distance like this, would the magnetic field be same? No. If it had been closer at a point like this, would the magnetic field be same? No. So it also depends on the distance r. So the greater the distance, they found that this Biot and Savart, they found that the greater the distance, lesser the magnetic field, and it varied in an inverse square form. So these were the four factors on which the magnetic field at a point P at a distance r from the current carrying conductor depended. Now when these four factors were combined, it was found that dB was proportional to I dl sine theta divided by r square. Now in order to remove the proportionality, we have to introduce a constant. So there is a constant dB equals to k I dl sine theta by r square, and it is found that this constant k, that is the constant k, is equal to mu naught by 4 pi, where what is mu naught? Yes, it is the permeability of free space if we consider that the space surrounding the wire is air or free, that is vacuum. So this is permeability of free space divided by 4 pi. Now what will be the magnetic field due to the entire wire? It will just be, so if B is the magnetic field due to the entire wire, it will be integration over dV, and we get our answer. So this would be integration over mu naught by 4 pi, which was our constant, I dl sine theta divided by r square integration. This will give you the magnetic field at point P due to the entire wire, and it was given by the two scientists Biot and Savart, and that is why the law is known as Biot Savart law.